Welcome to Chapter 2 of the Shapley Values series. In this chapter, we want to discuss the common trade-off between explainability and model complexity that machine learning practitioners face when wanting to create powerful yet interpretable models. Let's jump right in. Remember, our overall goal is to understand how the input data values affected the prediction example. But how can we get to this information? We can try to read this information directly from the machine learning model's parameters. This is relatively easy if the machine learning model that was used to derive the forecast is simple in nature. Imagine, for example, a linear regression model was used to generate the forecast. For such a model, one can directly see which data has a positive effect for the specific prediction, which data has a negative effect, and how big or small the effects are for different data. Let's say the price was 2.5 euros. The inventory level was 50 pieces. There was no sports event, indicated by a 0, and the temperature was 20 degrees Celsius. That means the price effect on the final prediction can be calculated as 2.5 times 2.5, which equals to 6.25. The effect of inventory was 25. The effect of sports events was 0, and the effect of temperature was -4. But what if the machine learning model is more complex? Often, more complex models can be more expressive. That is, they can improve the forecast quality significantly. That means many machine learning models you come across in reality will be more complex than a simple linear regression model. Let's take a deep neural network as an example. Here, a prediction is the result of many abstract feature combinations. These complex relationships make it hard to read the influences of different data values on the prediction directly from the model parameters themselves. That means it's hard to identify how exactly the input data values contributed to the specific prediction. It is clear that the difficulty of reading a prediction's explanation directly from the model's parameters increases significantly with the model's complexity. There's a trade-off between model complexity and ease of explainability when wanting to read the influences directly from the model's parameters. What we want, however, is to be able to use any kind of machine learning model, no matter how complex it is, and be able to explain an individual forecast from this model just as easily as if we were using a linear regression model. To do so, we want to use something we call an explainability model. An explainability model is an interpretable approximation of the original model. An explainability model can be wrapped around every machine learning model and provides easy explainability even when the machine learning model itself becomes increasingly complex. We have now understood that we want an explainability model to navigate the trade-off between model complexity and ease of explainability.